Thanks everyone for joining us today. For those of you who don't know me, my name is Fernando Martinez. I'm the Associate Director of Education Community Programs for the Center for Smart Streetscapes. And I'm very excited for us to be with a CS3 alum today, Fanchen Bao, also a Florida Atlantic alum, and currently a software engineer at Google. So we take this time to learn more about Fanchen's experience. He has a presentation that he's prepared for us that'll walk us through his academic and professional experience. And then we have a couple of questions that'll help guide the conversations, and then we'll open it up to just audience Q&A. So I'll turn it over to Fanchen, and if you want to share your screen, we can start the speaking.
Okay, I'm gonna try to share my screen. Okay, you guys can see my screen?
Yeah.
All right, so before the Q&A, I like just to give a quick background of myself. So you guys will know who I am. So make the conversation more fun. So these are the topics I want to go through. So I'll first talk about who I am. I'll briefly go through my academic journey. And specifically, I want to talk about the research that I did in CS3. And I want to talk about also, is getting a PhD worth it? The quick answer is yes, but I'll elaborate. And also why I think CS3 is a good choice for a graduate student. And then finally, if we have time, this is just some unrelated stuff that I recently get a little bit more experience on, is like about generative AI. It's kind of very hot topic right now. And if you have any questions, you can just stop me and then ask. It's fine. Okay, so my name is Fanchen Bao. This is how it's written in Chinese. I was born and raised in Shanghai, China. I came to the United States in 2012. That was quite a long time ago. Most recently, I got a PhD in computer science from Florida Atlantic University. After that was about two years ago. And after that, I worked in a few jobs. And then right now, I'm currently a software engineer in Google. I'm based in Seattle. So in my spare time, these are my two biggest hobbies. I like to do weightlifting and also like to solve legal problems. So this is the academic journey summarizing from the end of my undergrad until now. So it's a long list, which kind of shows a lot of poor choices I've made over the years. So it starts with the undergrad. I was a biology undergrad because when I was in high school, people say the 21st century is life science century, right? So I got into this, but it turns out it was not quite yet. So after that, I decided to go for something more application related. So I went into a forensic track for the PhD in biology. So I blame this on CSI. So I watched a lot of that in high school, and I decided, you know what, it will be fun, right, to go do forensics. And in specific, it's forensic entomology. So it's studying insects, how their how their growth on a corpse can determine the time of death. So that was fun, but yeah, it didn't work out. So I grabbed a master's of it and I just bailed. And then while I was doing all that, I got hooked in lifting weights. And I decided, you know what, if I like lifting weights, maybe it's good to go into the exercise science, be a trainer. So I went to Florida Atlantic University. They have a very good exercise science program. And I did my master's in there. And I actually became a trainer, working with athletes and whatnot. I did that for a year, but that's also, it's too tiring. You wake up too early in the morning and you go to bed too late at night, and I didn't like it. And after that, I decided, you know what, it's time to really settle down. So that's when I decided to go back to school and pick up something I think it's like I like the most at that time, which is coding and stuff. So I went back to Florida FAU. I picked up some courses, but most importantly, I met this guy. I think he's in the audience right now. So this is Dr. Jason Hallstrom. I think one of the most important person in my life that kind of changed the trajectory. So I took one of his classes, and me being me, not really respecting authority, so so I constantly challenge him when he was teaching. And granted, I think that was his first time teaching the algorithm course, so there were some rough edges. So I grabbed onto those, and I kept challenging him, and he was very receptive to these challenges. So we have a lot of back and forth, and I decided, you know what, this is the guy that I can work with. So I asked him, hey, you have any program for a grad school type of stuff? And he said, yeah, there's a PhD spot open, and then why don't you join me? And I said, okay, I'll do that. And that was kind of the precursor of all the CS3 starts from there. So I think the point of sharing all this is kind of just point out that it's definitely not the end of the world if you make poor choices, or like in my case, a lot of poor choices. I'm also privileged that I think all these programs have scholarship, so I don't really have to pay out of pocket too much. So I got scholarship for all of them, and they support the tuition. I have a stipend, and also I have parents that are very supportive of each of my choices. But I mean, the bottom line is, if you make a poor choice, it's fine. Like, it's definitely not the end of the day. So moving on to the actual research that I did for CS3. So this is I think it's a very interesting project. So what we're trying to do is, I mean, it can summarize in this sentence, right? So it's a Wi-Fi, RSSI-based passive localization. So I want to explain each one of them. So Wi-Fi, we all know this on our phone and in smart devices, they have Wi-Fi, right? RSSI is just a fancy term to call it signal strength. So basically, it's a Wi-Fi signal strength based, right? And then we want to do localization. Basically, you have a phone. We want to know where it is using the Wi-Fi signals. And we want to do it passively, which means we don't want to exchange any information from the phone. We don't want to know what the phone is. We don't want the phone owner to know that we're actually tracking them. So that's essentially what this is. Like, as you are walking on the street with your phone, and nowadays our phone always have Wi-Fi on, and they will constantly send some signals, uh, completely private type of signals. Like, there's no privacy concerns, and then we want to use these signal strength like a semi GPS system, but very local, very localized, and we're trying to identify, predict where the device is. And it's a very cheap system to set up because most of the components can be bought off the shelf, and it has a very high privacy guarantee because we are not doing any signal, we're not doing any message transfer between us and the phone itself. So it's good for cities, like if they want to know what's the population flow on the street, when there's a peak of population, how does the population move around in the city? So this will be a good way to provide these data-driven decision making for the city planning, and also for emergency response. So it's a very good project, and it fits very well to what CS3 is aiming to do. So in this whole project, I spent about 4 years on this project. Starts with building the sensors, and we deploy the sensors along Clematis Street. It's a commercial street on the West Palm Beach. So you can see I highlighted this little box is the sensor we put. And I think eventually we got about 50-ish sensors deployed along the street. So on Clematis Street, you have these light poles, and most of them have outlets. So we just put the sensors up high, plug it in, and then just constantly monitor the signals that's in the air. And by doing this, we get to have an idea of population size. Because if there's a device nearby, we capture its signal, then we know, okay, this most likely a person's nearby. So by doing some extrapolation, we're able to gather what's the population change over time. And you can see, like, we have, like, when it's like early in the morning, really early in the morning, we have low population, but then in the afternoon towards the evening, we have a high population. So this is kind of a more qualitative view of how the population size change on the street. And ultimately, this is what we want to do, is to do the localization. So basically, we want to see if we have a device that's sending signals along the street, what will be the accuracy that we can get by predicting where it is. And I think we get down to about 4 meters accuracy within, I think, 70 to 80% of confidence. It's not it's not the best, but I think it's a good start for us for any more research to move on in this space. So I think this pretty much summarized all the research that I did in the CS3. So moving on, the next I want to talk about is PhD worth it? Well, yes, I think it's a big resounding yes that it's worth it. I think the first reason that I think it's worth it is because I'm getting paid to learn, right? I have my I got a stipend, I got a tuition waiver, and then I just be there and then learn stuff that otherwise I'll never have a chance to learn. For example, in this CS3 project, I have to do some embedded programming, something that I never even imagined that I will do. I mean, I call it embedded programming, but yeah, that's we have a lot of help from iSense in FAU to help us actually do the part. But I have to learn some of the terms at least so that I can talk to the real embedded engineer to get these sensors built, right? And then it allows me to do some like pull request injection, like something that's related to the Wi-Fi chip. Like I never imagined I would do that. Or I have to do things like writing a mobile app, right? An actual mobile app, because to collect data, we need a mobile app to coordinate things. So like all of these things that are very outside of my comfort zone, but because of doing PhD, because I'm the only one responsible for all of this, and I have to figure out how to do this. So this is definitely how a person can learn, right? I mean, I can push my boundary. So that's the first reason I think PhD is worth it. And also, I got to learn not to be scared. There are a lot of scary things in the world, and I think these things are pretty scary. You have a deadline, right? But I mean, being a PhD student, you basically have to eat deadline for breakfast, right? You have deadline from your classes, from your term projects. You have your committee meetings, right? You have your advisor going on your tail, like, hey, I asked you to do this. Have you done it? Like, there are so many deadlines coming at you, but you deal with it enough that you know how to deal with them. You know how to time box your schedule. You know which one is more important to do, which one can be like, we can delay those. So you know how to organize your life. And there are a lot of high stake situations that people can get scared of. But in PhD, there is something called a qualifying exam that if you fail, you're I think you get another chance. But yeah, it's a very scary thing. And but in doing PhD, you have to deal with these high stake situations. And most importantly, presentations. This is something that a lot of people might be scared about, like how to present. But to do a PhD, you have to present all the time. You have a committee meetings, you have to do poster sessions, conference, right? And of course, at the end, you have to do a dissertation defense, right? That's like presentation after presentation. And every time you do this, you get practice and you get better. So all of these seemingly scary stuff, and as you go through a PhD, they no longer become scary. Next one, you learn how to write. I mean, by writing, you can even extend it to how to communicate, right? It turns out writing is very important. It's not just for PhD, but like right now at my work, writing is a very big part of it. I mean, for PhD, like you have to write a paper, right? And then most importantly, you have to convey a complex idea to people who might not have any context about it. And it seems to be like you know everything in your head, but once you put down in the paper, it's a very different story. And when I say it helped me in the work, because in the work, there is something called design documentation. Like when you want to build a new system, when you want to build a new application, you have to write a design, like what type of input you want to put in, what type of output, what type of situations you might expect to go wrong. Like all of this is about writing. And through a PhD, you learn how to write, right? And On the other hand, you also learn how to read your advisor's handwriting and then getting frustrated about it, right? So yeah, it's a very good thing. Like when you submit, like you wrote like 10, 20 pages of paper, you feel so good. You send it to your advisor, and this is what came back. And you just go, what am I gonna do with this? And then your advisor will put at the end, oh, great job. Keep it up. You're like, okay, at least he said it's a great job. All right. But this is type of the thing that really get more practice. I mean, again, I constantly coming back to this. It's just during PhD, you get practice to do a lot of the things you don't realize you got to do, but they're very important in a professional life afterwards. And finally, it's collaboration. You collaborate with your peers. You collaborate with people who are more senior to you. This is very important. Now that I'm at my workspace, I constantly feel it, because you need to know during a meeting, you need to defend your idea, right? But you also know when to stop, right? When to acknowledge that, yeah, probably your idea is not good enough, or when to say yes, I'm going to do it, and when to say no, and also when to say I don't know. Like you don't say I don't know, but you say, you know what, this is not, it's out of scope, right? You learn how to do this type of thing, and these are very important things in the workspace. You have meetings with senior people. They are asking you to do this. They don't understand how complicated these things are. They just say, I want this feature, I want that feature, but like not possible. So you have to work with them. And the same thing happening in PhD as well, because you have a committee meeting, you have professors, you group around. Your advisor knows, but the rest of them don't know. They just say, yeah, I think you should do this. Actually, I think you should do that. But you need to work with them. And this type of experience, like working with other people, is also very, very helpful, right? And the big tech loves hiring PhD. So this is just from what I experienced earlier this year. I think it's not confidential, so I can really share. So I work in Google Cloud, and earlier this year, I did a lot of interviews, trying to screening people. And I would say, except from the rehiring or people who have really years of experience, I say 90% of the new hire that at least Google Cloud is doing now is PhD. PhD presents a lot of advantages. They're hardworking, because getting a PhD really, and like I say here, it's like being a PhD. It's not really about how smart you are, but it's more about how diligent and how you can get things done. And these are the qualities that big companies really looking for. And also PhD years, they count as a work experience. So when Google Cloud, when we are hiring PhDs, you're not hired as like undergrad. You're hired as a slightly higher level, because the company recognized that your experience getting a PhD itself, right? It doesn't even matter from where you get it. It doesn't even matter the exact field. It can be machine learning. It can be physics, mathematics. We have different types of PhD. But just the fact that you went through this and you get all these experience, that's what big companies really value. So to sum up of this, I think getting a PhD is worth it, because it pushes your boundary, it gets you outside your comfort zone so you can grow, and it teaches a lot of things to not be scared, right? You get practice to write, to communicate, and you get practice to collaborate with other people. So all of this, right, they help you to get your PhD, but at the same time, they also help you in the actual workspace. And I myself benefit a lot from my experience doing a PhD. And there are many places to do PhD. And I think CS3 is a great choice because it has great funding. So this, again, I'm very appreciative of what Dr. Hallstrom did, that during my years at PhD, I didn't have to teach at all. I was a research assistant all the way through, which is actually not a trivial advantage. Because I don't have to teach, I save, I don't know, 10 hours, 10 to 20 hours a week. I can keep digging on the things that if I had to teach, I probably wouldn't have time to do. So this is definitely an advantage. I feel this very well. Like I have a lot of GitHub repos set up just because I had that extra time and extra energy to go dig deeper. So that's definitely a big advantage. And another advantage is, I mean, this is not related to me, but this is related to my coworker that he wanted to try some fancy algorithm, but it requires us to buy a very expensive router. I think it's $500 router. I don't remember, but it's very expensive. And we're a little bit iffy. Like, wow, it's like very expensive router. What are we gonna do about it? Can we ask Dr. Hallstrom to get it for us? So we just ask him, and his response is always, "Yeah, go ahead, get as many as you want. Doesn't matter." Like this type of like safety in the research. Like you don't have to worry about is this possible? Is that possible? No, it doesn't matter. The limit is your imagination. The limit is the amount of work you can put into it. Any roadblocks, any money that CS3 is able to find you. Your advisor is able to find you. So I think this, like these two things, would really like put a rocket behind your research. And also CS3 is very wide. Like it includes a lot of colleges, a lot of university, a lot of collaboration as possible. I was very early on, so I didn't have too many collaborations, but I went to quite a few conferences. I talked to people, and these experience is also like very valuable, and including industry side as well, because CS3 has an industry arm, so you're able to network with the industry people, get to know what is the current trend, what the industry actually looking for, right? So all of this put together, which I think can make CS3 a very, very attractive place to do this PhD thing. So finally, I want to talk about a little bit unrelated, but with the generative AI. I think this is the biggest trend right now, and I am positive on this. Not just because the work I'm doing actually very related to this, and it's mostly because I start to use it and I see the benefit. So the example right now for me is I need to learn C++. C++, I learned it, I like quote unquote learned it in school, but when you write production level code, whatever you learn in school is not enough. And I was dreading it because now they put you on this job, they put you on this task, and you have a deadline. So like, I think I'll need a month to learn C++. But then they say, oh, the deadline is like 3 weeks. So what should I do? Then I just turn to generative AI. Whatever question I have, I ask it, right? And then generative AI will give you some response. Now, the key here is never trust it 100%, but the AI is good enough to point you to the right direction. And a lot of times, especially when we deal with new stuff that we never seen before, we never done before, we don't even know where to start, right? You have to like read a lot of books, blogs to just to know like which direction you should go. But if you ask generative AI, it points you to the right direction immediately, and then from there you can do your learning. And because of this, it helps me tremendously. It helps me tremendously. And now I start thinking about like what generative AI is, right? So it follows the revolution, the evolution of how software engineers finding answers. And I think about it in the early times when software engineer first start to become a profession, you have to read books, you have to go to talks, you have to be on the mailing list, go to obscure forums or read some guru's blogs. And it's very scattered, right? You need to read a lot of things to learn. And then later on, Google came about, you have Stack Overflow, you have GitHub discussion, so you can query specific questions, but then you still have to read all the articles, right? But it shrinks your search space. Now, generative AI, what it does is it consumes all this data for you, and when you ask it, it further shrinks down the search space. So you get a very specific and relevant answer to your question. But at the end of the day, the AI is just a tool. It's the same thing. It's like books. It's like Stack Overflow. It's just a tool. And it's about the people who are using it to determine how to move forward. And there are a lot of hype right now about the AI. I don't believe in this hype, right? They say a software engineer will be irrelevant. The job will be gone. I don't think so. Because to build a software is way more than coding. There's a big difference. But AI does have its place. I think if you think AI is really good, then you may be gullible for the hype. But at the same time, if you think it's like nothing, it's like just a gimmick, I think you're also uninformed. And I encourage everyone to try it. Like it is the future. It's like I feel like we're in the early stage, like when the internet first came about. There are a lot of hypes, there are a lot of doubts. I think AI is the same thing. And for software engineer, I think AI will be a big productivity boost, at least from my personal experience. Okay, that will be it. I think I hope I didn't take too long. So that's kind of the background.
Thank you, Fanchen. I see everyone's clapping over at FAU. I did have one question since we do have a big audience at FAU of undergraduate students. So thinking back to your undergraduate experience, what advice would you give to yourself? Because maybe we have some students here that are thinking about continuing their education after their undergraduate degree or maybe going into the workplace. So what advice would you give to an undergraduate student currently?
I would say if you have a chance to further your education in grad school, I think that's definitely a good way to go. I mean, talking about the job market right now, fresh undergrad, it is getting harder to be hired if you just have an undergrad degree. Usually, you need quite a lot of internship. So if you don't want to do a grad school, you have to focus on like aside from academic, definitely, but you have to focus on internships, because companies like because I was part of those screening for candidates. We do look at your GPA and stuff, but overall, that's not really a big thing. Like if I see a resume with kind of quote unquote low GPA, but then you have a very impressive project that you've done or internship you've done, that the GPA is really irrelevant. So big companies look for experience, a track record that you can get things done. And if you are very motivated and you do external stuff, like don't just focus on your academic, you try to do some open source, right? You try to create your own projects, you try to maintain a GitHub repo. That's good. I think these things definitely help. But if you have trouble finding these projects, have trouble getting motivated, grad school, because it's like don't think about graduate school or getting a PhD is like yeah, I have to study more. I study 4 years. I think about it's just a big project, right? It's just a big project that you do, and along the way, you accumulate a lot of experience, and all those experience will show up on your resume, and it help you grow, right? And this is kind of just my advice. Like if for undergrad students, if you're motivated enough, if you're resourceful enough to find these projects yourself, I think they are very important, right? If you can get internships, very important. But uh, if you have trouble getting these things, then yeah, grad school will be. It's like it helps you to do all these things. So that's kind of my advice.
And one more question. So, we heard that Dr. Hallstrom played a pivotal role in your academic career, a mentor of yours. So, how do you encourage people to find mentors, or what is the best way to like find a mentor?
To take a when you take a class, okay, this is my advice. When you take a class, challenge your professor. I think this is the one of the best way to really tell who a person is. Um, of course, you need to do your work, right? We all make mistakes. Professors make mistakes, right? So when they make mistake, I encourage all the students to be brave, to raise your hand, and to challenge him, challenge her. And then you will have some interaction. And during this interaction, you will know what that person is, right? Is that person just shut you down? Like we have professor like that. I have experienced professor like that. Or would that be a professor that's, would think it over, will talk with you, and even like in Dr. Hallstrom's case, he corrects himself during the class in front of all the students. Like this type of quality, you won't be able to know if you are, let's say, always go to class remotely. So that's kind of the thing, right? If you always do remotely, you always hide behind the screen. These type of interaction don't happen. So at least you have to go to class, talk to the professor a few times, right? Interact with them, and then to just get a feeling. I mean, we're paying to get an education, and to me, it's a two-way street, right? So the professors they teach you, they impart knowledge on you, but for us, it's the same. For students, the same. You're also evaluating the professor, right? Because the best way to learn is if the two of you is on like kind of on the same bandwidth, on the same wavelength. So be brave to challenge them, and then you will know if they are the good one. And yeah, take lots of classes for each class to challenge, to get to know them. And then once you find one, which I believe every school has at least some of these professors, and then just grab onto them, just ask, email them. Yeah, is there any opportunity out there? It doesn't have to be a grad school position. It could be a summer research program. I think CS3 runs very successful undergrad research program in the summer. Like all of these opportunities that you can take from just by challenge your professor to get to know what type of person they are.
Thank you. So I'll open it up to anyone that has any questions from the audience. Feel free to unmute.
I have a quick question. I can kick it off. Thank you for your presentation. This was super informative and really fun. So thank you for putting some levity in there. You talked about how academia prepared you to present better now that you're in the workforce and in a professional setting. I know you probably can't share every detail about your work at Google, but I think it would be great to hear an example of what a presentation looks like now for you that you're at Google. Maybe like the broad strokes of how you prepared, what type of roles the people were in that you presented to, and how presenting as an academic prepared you, or what was really different.
Yeah, thank you very much. Very good question. So in my current workspace, there are generally two types of presentation I do. One type is we call it knowledge sharing. It's basically something that you learned during your work, because the team is big and each team has sub teams, and when you work on your stuff, you go very deep, and then your other teammates from other sub teams, they might not have context, so you share this with them. So this is more like what I'm doing right now, kind of just sharing, and it's very similar to a conference in academia. You have some data, you have some knowledge that other people don't know. You share with them. You try to share it with them in the most simple possible way. So that one is, I think it's not the most difficult. Usually the feedback will also be benign because the audience, they don't have the full context. Another type of presentation is like more focused. It's like in your small team, you're presenting to your team lead, you're presenting to senior engineers, some people who might be 2, 3 levels higher than you. And they assign you a task. They say, okay, you need to design this system, and you design it and you need to present it to you. Okay, this is my design decision. I would like to have a factory function to creating this class. And then for this factory function, I would like to have these inputs. And then these I want to be private functions. These I want to be public functions. So all these design decisions you need to present. And then you get challenged because the people you're presenting to, they have more experience. So they will just ask, why, right? Why do you think this has to be a private function? Why do you think that has to be a public API? And then this is more like in your committee meeting, right? You're presenting your work, and then your professor is asking you, yeah, I don't think that one's right. And then you need to explain to me, what does that mean, right? Why do you think it has to be this way? So this is the practice from the committee meetings, right? From the committee meetings, from the talk with the professor that prepare you. So you know that when you're doing this design, you have to think ahead of time. what type of question would they ask, right? And so instead of just say, yeah, I think this function should be public, you have to ask ahead of time, why does it need to be public? Like, is it need to be public, or it can be private? So you have this kind of self-conversation beforehand, and then when you actually present it and you really get challenged, so you're prepared. So it's the same thing. It's the same thing during my PhD. But I mean, during PhD, you have your advisor who will help you, because I think with Dr. Hausram, we usually do a dry run. So to kind of go through all the rough edges. So he will kind of prepare me for these things. But in workplace, there's very little chance for these dry runs. So you have to prepare yourself. But all the learnings from the academic training, it works very well right now. To me, it's the same. I think this also kind of the reason why, at least for Google Cloud, they prefer PhD candidates to PhD students to be new hire, because they have this experience, and this type of thing happen every day, multiple times in the workspace.
Awesome. Thank you.
Any other questions? Yeah. I think if you're all talking, we can't hear you.
See, this is also part of the high-stakes situation that you will encounter when you're doing your PhD, the technical issues. And no matter how many times you prepare before a committee meeting, things like this will happen.
So true.
Yeah. Yeah, you prepare a demo, but the demo didn't work. It never works. It happens in workplace as well. Yeah. I think they're chat.
Yeah. Okay. Jason claims that the conference rooms work equally as well as when you were here.
I'm on the edge of my seat right now. There we go.
Okay, so first question, please describe the ideal meal regimen for PhD students based on your personal experience. It seems like an inside joke.
Yeah, it is an inside joke.
Second, if you were starting your PhD again, what would you do differently? So feel free to answer both questions. I really do want to know about this meal regimen.
So I'll answer the first one. I'm not a nutritionist. Oh, okay. Yeah, I'm not a nutritionist, but I did study. Like I said, I was studying exercise science, so there's a nutrition part to it. Dr. Hausman poking fun at me because he saw my food.
There's an input.
I think we can hear you.
He hears me.
Yeah.
Can you hear us? Oh
Oh
gosh.
yes, I can hear you. Yeah, he was always poking fun at my food because I ate lots of soybeans and tofu, and then he was I mean, ideal meal regimen for PhD students. Well, all I can say is get your protein in. Doesn't matter what type of protein, and that's why Dr. Hausman saw me eating all those soybeans, because that's my main source of protein. And you get your protein in, you get your essential fat in, and then you use carb to fill out the rest. And that's basically it for me. And I mean, PhD students doesn't have too much to spend, but it's fine. You put some efforts into it, you'll find out that the stipend goes a long way, until you go into a workplace such as Google, which provides free food, which I think if people ask me why I work for Google, I think this actually ranks very high on my reason, because they have free food, they have free breakfast, free lunch, and free dinner. I haven't gone to do grocery for months. Okay, second question. If I start my PhD again, what would I do differently? That's a good question. I think what I would do differently is definitely I would read more papers. There was a time, I think, when I first started implementing my ideas, and I had all these, I had all kind of how I want to do it, and I just go ahead and do it. Didn't really consult with other people. Didn't really read the paper to know what is the current trend, what is the current cutting edge kind of methods to do things. I just go ahead and then try to build stuff out of my own head. And then it was after, you write up your paper and you even submit it, and then people say, have you considered this, right? Have you considered that? And mind you, your advisor might not be the expert in the field that you're doing. And that actually should be the case. You should be the expert, right? Your advisor will give you the general direction. You're kind of pointing out the obvious flaws, but the details is all up to you. And I think I didn't do a very good job going through all the papers to learn what's the most advanced technique in a lot of analysis. And that caused a lot of waste in time, because basically I have to go back to read them again and re-implement the stuff. And if I had to do it again, I would spend more time reading papers. And also it also helps. The more paper you read, the faster you can go through them. I remember when I first started reading papers, like 10, 20 pages of those technical stuff. I don't even know where to get started. But then you read enough, you know which ones are fluff, they just put in there, and which ones are like the dry goods. So yeah, I think this is what I would do differently. I would definitely reach out more, read more papers, maybe even email people more, talk to more people to get a better understanding of the current field.
Awesome. Any other questions? I think you're unmuted. I think we can hear you now. At least we could. Okay, now we can't. No. Okay. I can't tell if there's a question coming from the group or not. But
Test. Oh, there we go.
There we go.
No, you can drag, those to the side.
Maybe. Oh, yeah. So
Can you hear
Can
us?
you hear us?
yeah, we can.
Yes.
Oh, we don't know why the system is behaving the way it is. No, I don't. Do we have any questions on this side? Oh, we do have one from Jan Eric.
So one of my questions here is that as an undergrad, I really want to kind of work on my resume and develop projects and such. So outside of, internships and research, firstly, is there anything else that would be really helpful to kind of add to your knowledge and to your kind of list of projects? And for something like a personal project, how do you go about figuring out what you want to actually do or create?
Very good question. I had that question myself. At the end of the day, it's from my life, which part of my life I feel is being troubled. So I will just go through my life and find all the friction, the things that I like. during your life, you won't even think about it, but as you go through your life, you will be like, I wish somebody can have like build an app for like do this, right? So like this type of moment, I can give an example that I want to build, but I never really had a chance to build. Is I use Spotify, right, to listen to music, and Spotify. I'm very cheap, so I don't want to pay for them. So I have to listen through the commercials, and I hated it, like because I was listening to some music, and then suddenly a commercial comes up. So I had this idea, like, can I build something that whenever the commercial plays, I'll automatically mute my laptop, so I don't have to listen to them. And then when the commercial ends, and it will automatically detect it, and then the sound will come back up. So this is just from my daily usage of Spotify. I come up with this idea, and then when you have an idea, it doesn't matter how big or how small, and you start to look into it. Is this even possible? So you start to go into Spotify, their API documentation, right? What type of information is Spotify API supports? And I find out, yeah, they have an API that does have a tag to show when they're playing the commercial and when they're playing the music, which means I have a way to hook up to it to control like the sound volume. And then you start to think, okay, but how do I like turn the volume up and down on my laptop? So you have to go down to I'm using a MacBook. So what type of command in the MacBook can do this? So from one idea, right, just a small friction in your life, and you start to branch out. You start to read things that you didn't realize you need to read. And then you start learning new skills, like how do I even communicate with an API if you haven't done this before, right? How do I communicate with a system to turn on and off the volume? And how do I put them together into an app so that I can run it in the background like all the time? Like just this type of thing is where ideas come up, and then where things go on. And another part is we always have term projects from your class. And the term project from class sometimes are very limited in scope, which is fine because it's just for a class. But you don't have to limit yourself to the scope, right? So the scope is, oh, let's build an app. Let's build, like I remember in my Intro to Programming Language C class, we have a thing called build a stock trading app, right? It's very simple. You just you can provide the ticker name, and then you can say I want to buy at this price, sell at this price, and that's it, right? That's just the scope. But you can add more, right? You can add more. What if I can fake some data? Like, can I fake some stock exchange data into my app so to make it more real? Right now, you have to figure out how do I fake these data, right? And you can even think more. There are APIs out there for stock market. Can I hook to those APIs, like pipe those data into my app, so my app becomes a real one, like the data become real? Like all of this just starts from your term project, but you start to think more. And every one of these, even if it's just a small school project, I encourage everyone to put it on GitHub, right? To write it up, put it on GitHub to make it presentable, because every one of those will become something that might help you in the future. You never know. You never know. Like in my case, I have some machine learning stuff just from class, just from, I think it's a reinforcement learning class. I put it on just on GitHub, term projects. But then it becomes something that during hiring for my current role, because it has to be like related to machine learning. See, they went to my GitHub and they find out this. They're like, oh, this guy knows reinforcement learning. I don't. Okay, I don't know reinforcement learning, but I did a class on this, and I spent a lot of time programming the stuff. But it's on my GitHub, so I am labeled as I know. But it doesn't matter. It gets you in the door. It can always learn afterwards, right? I mean, I hate the term of fake it until make it, but sometimes it applies. So long answer short is just to go through your life to find any sticky point. Again, from there you'll have ideas, and also to expand on your school projects, and that will also give you more ideas.
Thank you so much. So we're about at time. So I'd like to thank Fanchen again for sharing your experience, making it so fun for all of us to really learn more about how you journeyed through academia into your current role and for sharing advice for all of our students here. And I wish everyone a great weekend. Happy rest
Yeah,
of
thank you very much. Thank you very much for this opportunity to share and to see some familiar faces.
Okay, everyone, have a great Friday.
Thank
Bye.
you. Bye.
Thank you. Bye.